All right, guys, I want to explain a little bit about air pressure today. You did this lab, you drew this map B from the lab about barometric pressure. And I just want to explain why these high and low pressure systems will create changes in the wind and will obviously create the precipitation and the weather that we have. So all of these maps really kind of come back to this map B that you guys did in your lab. These wind patterns that you see on this map here, map C, are related to all of that. So I just want to explain why that's true and why we have precipitation in this area of low pressure and how that all relates to the cold fronts and warm fronts that you guys basically put together in your lab. Okay, so we're just going to kind of explain the process behind that. So we really want to start with just what is air pressure. And you got to realize that air pressure is created by the fact that air molecules have mass and take up space, and therefore they have a force that is exhibited on everything that they come in contact with. Now here at the surface of the Earth, the air pressure is greatest because there's a lot of air above us. And so all the air molecules are essentially colliding with objects around us, including yourself, and they create about 14.7 pounds per square inch at sea level. So that's quite a bit of air pressure. And you can do a demo with that with this egg in a bottle trick where you basically create a partial vacuum and you heat up the air inside of the bottle, put an egg on top of it, and once the temperature is really, really hot, all the air molecules escape, as you can kind of see with these red arrows here. And then once they all escape, you've created a vacuum, and so all the air pressure on the outside will push that egg into the bottle, and because there's quite a bit of pressure from the air molecules outside. Okay? I'm going to light this paper on fire, and I'm going to stick it inside of the jar. Okay, and then I'm going to put this on top and watch what happens. That's just a quick demonstration of air pressure, the fact that air does have mass and take up space and therefore creates pressure. Now, the one big takeaway from this lesson, and we're going to mostly focus on this today because there's a lot to this, is the idea that atmospheric pressure can be changed by a few factors. And we'll talk about all these individually. I think you all know that as you go up in altitude, the air pressure decreases. I think you probably have experienced that because your ears will pop maybe in an airplane or when you're going up and down hills. And so you know that altitude will obviously create a change in the air pressure. Now, if that's true, that's true because of, this graph right here, which you can see at sea level, the air pressure is 1 atmosphere. And that's just because there's a lot more air here at the surface than there is higher up in the atmosphere, and therefore you are going to have less pressure up above us. Okay, so differences in pressure can be caused by that altitude change. Now, the other thing that's important here is that temperature can cause a pressure change. And it's all kind of based upon this simple diagram right here, this simple kind of breakdown of everything. As you decrease the temperature, so we're focused on, decreasing the temperature right here, okay? And as you decrease the temperature, just think about what happens. Well, the air molecules will slow down. They'll become more lethargic, we might say. They'll take up less space, and therefore they become closer together. So we would say that the density is increasing when the temperature goes down. Okay, they're getting closer together, so increased density. They're more packed together. And when we have things more packed together, they're going to give off more pressure. Okay, and so if you look here, you'll notice that there is basically an inverse relationship between temperature over here and pressure over here. So when you drop the temperature, the pressure increases. Okay, that's important to take away. And also notice when you decrease the altitude, that increases the density of the air, which increases the pressure of the air. Okay, humidity we'll talk about a little bit later on. Humidity does the same thing, but I just want you to notice that relationship between all of those factors and how that influences atmospheric pressure. So we've talked about this. Let's come to this whole idea of regional wind. Okay, so we have areas on the Earth's surface of differences of pressure, either high or low, and that's all based upon the fact that we have differences in temperature on the surface of the Earth. So a low pressure system is an area where you have a lot of warm, humid air that is converging, coming into the center. As you can kind of see in this picture down in the bottom corner here, we see this low pressure air where all the air, all the wind is kind of driven into the center of that thing. And so as it comes into the center, we call that converging air, or a zone of convergence. It has nowhere to go but up. So if you look here, all this air is coming into the center and then rising up into the atmosphere. So we have this rising air that's very, very humid. And because it's humid, there's a lot of moisture content. And as it cools off, it reaches the dew point, and eventually we are going to create a cloud, which we already talked about how clouds are formed. And so we have a lot of cloud formation in this low pressure area. And as this rises up even more, all the collision of those water molecules within that cloud and the ice that's created at a higher altitude, we're going to start to precipitate all that water out. And so we have in a low pressure zone the creation of clouds and therefore kind of lousy weather. So you can always think low pressure equals lousy weather. And this diagram shows pretty similar stuff here. You can see all this rising air being pushed in the center. And as it rises up, it creates a cloud. And as it expands, that expansion causes the air to cool. And then when you cool stuff down, you create clouds, condensation. So just remember all those kind of words are associated together. Converging air, rising air, cooling that air off, forming clouds. Okay, and you get a lot of rain as a result of that. So if you consider back with your maps from before, I'll go back to the actual low pressure map. This area that we see on the map of low pressure is associated with those same conditions. All this air, you can kind of see in the diagram, all the air is coming together in Cincinnati. It's kind of all centered in there. And as a result of that, you have a lot of rising humid air, and therefore you have a lot of precipitation in that area. And as you can see, the precipitation pattern over Cincinnati, very rainy conditions in that part of the country. Okay, so that's our low pressure. Again, associate low pressure with lousy weather. Okay, so let's come back to this, and let's consider high pressure. Okay, and we'll come back to this this idea of rotation later on. High pressure. High pressure is an area where we have air that is dry and cool and sinking back down again to the surface. So you can kind of see how it's all elevated up here and it's sinking back down to the surface and then spreading out away from the surface. Because we have all this air coming down, it's got to go away from the center, so it spreads out or diverges away from the center. And you can see that down here. We have all these air, the wind patterns are all directed away from the high pressure and outward in those directions. Okay. Now, this area of divergence leads to conditions that tend to be pretty dry. No cloud formation because we're not bringing the air up to a higher altitude. It's not cooling off and condensing into a cloud up here. It's sinking and actually warming up a little bit. Okay. So that is a high pressure system. And if you take a look at this picture right here, you'll see this area of divergence. So high diverge, spreading out away from the center. And you can see here that the conditions tend to be pretty dry, clear skies with a high pressure system. It doesn't necessarily mean that it's going to be always warm, but it definitely means that it's going to be clear skies. So sunny weather with high pressure. It's the complete opposite of low pressure systems. And if you consider back with our pictures over here, our high pressure out to the west in Salt Lake City, this area of the country, very high pressure. Look at the station models. You'll notice that all of them have clear skies, not necessarily warm, but definitely clear skies. And if you look at the wind patterns, you can see all the arrows are directed away from Salt Lake City. And if you look at the actual precipitation patterns, there's no rain over here on the western side of the country. Okay, so all of that is kind of related to the idea of that sinking dry air. All right, guys, just one other thing. This is a really easy way to kind of remember the difference between low and high. What I do is I draw a big L for the symbol for low pressure. And then if you think about the word low, okay, I can think about the way the air comes into a low. And when it's coming into the low pressure system, we call that converging. So I do this little way of remembering converge and low, okay? And again, the arrows would all point in towards the low like that, okay? The high pressure, same idea, okay, right, high. And this, remember that the air goes away from the high or out away from the high, or what we call diverging. So you can do this. Okay, it's just a kind of an easy way to remember the difference between a low and a high pressure system. Okay? So those are the two different pressure systems, high pressure and low pressure, and what you get as a result of it. And I want to just point out one other thing, and that's this idea that the air is always going to go from the high pressure area to the low pressure area, from high to low. That's always true with everything. High temperature to low temperature, high pressure to low pressure, okay? Now, just one other heads up about this. You'll notice that there is a rotation to this thing, and that's a little bit more complicated, so we're gonna be getting into this whole idea of the Coriolis effect, but I'm gonna leave that for a totally separate lesson. But I just wanna point out one thing about the high and low pressure idea, and kind of an analogy that you can kind of think about. Remember topographic maps, perhaps from earth science. And a topographic map which is showing a hill, which you can kind of see in the picture here, a hill is indicated by these circles that get smaller and smaller and smaller with higher values in the middle. So think about a topographic map when you're thinking about a high pressure map or a barometric map. The high pressure is the top of the hill. And so the air, just like a ball, would roll or blow downhill or away from the high pressure. And it would go towards the valleys, right? The water would run downhill into the valley, and that would be our low pressure. So kind of consider that this map that you guys drew the other day, here, go back to this again, is going from this high hill over here on the left-hand side, or the western part of the country, and it's blowing towards the low pressure valley over there. Okay, and air wants to go from high to low to balance everything out. And why do we have wind? Well, we have wind because air wants to move from high pressure to low pressure. Why do we have differences in pressure? Because of differences in temperature. Okay, so that's a big takeaway from today's lesson. What we'll do next is talk about why we have this circulation. Why does it kind of go around in a clockwise or counterclockwise rotation? So we'll talk about the Coriolis effect after this.